Hi everyone, this is my voiceover of Plan the Tech programming in LabVIEW videos that I originally created for my overseas audience, and now since there is some interest from my Silicon Valley community, I decided to quickly translate it. And today we continue exploring database management capabilities. Here we are looking at the GUI, the graphical user interface, in the LabVIEW development environment. There are many different ways to work with databases. Let's compare them. In LabVIEW, the GUI isn't something you fight with, it's something you wire once and immediately understand. That alone already saves a few years of your life. In the previous episode, we stopped at how, in 3 steps, we can get to the required table and start working with it. Using just 3 operations, we reach a user interface that allows us to work efficiently with databases. So, how is our approach different from the ones that are widely advertised online? If you set this as a goal, you can find dozens or even hundreds of user interface options offered by different developers. Let's focus on 3 of the most heavily advertised solutions: DB Visualizer, DB Forge Studio for MySQL, and HeidiSQL. Let's look at them from the employer's perspective and from the user's perspective. Imagine you're an employer and you need to provide some kind of tool for your employees to work with your company's resources and information. For example, an inventory specialist, a warehouse worker, a sales manager, or a store clerk. Let's try to apply one of these 3 options to one of these professions. For example, you're an employer and you hire an inventory specialist. You tell them, here's the program, and with it you will now work with the inventory, adding stock, entering vendors, setting prices, changing markups, and so on and so on. Many different functions. Where should the inventory specialist begin? Apparently first they need to become a part-time SQL wizard, which was definitely not in the job description, huh? They must start by learning relational relationships, semantics, cell properties, bits and numeric dimensions, and finally the syntax of the SQL language. In other words, the inventory specialist essentially needs to have a second profession, that of a highly skilled programmer. In addition, you must trust this inventory specialist with your data with which they can intentionally or unintentionally form actions that consciously or by mistake can simply destroy your business. Let's consider how this could happen. For example, the inventory specialist makes a mistake in SQL code. Here you see an example of SQL code that they are supposed to enter, where an operation is performed on a structure related to company employees. By making a mistake in this code, it can easily happen that a record disappears or that record gets rearranged. In other words, we see that the inventory specialist is not limited in their actions in any way. One missing character in SQL, and suddenly your database learns the art of disappearing records. Let's look at the second advertised program, DB Forge Studio. What is the difference here, apart from the color scheme being light instead of dark? Yes, we also see an SQL command that performs an operation, which you see after the hash symbol. That means here the inventory specialist not only needs to enter the command, but also describe what action is intended in that command. Now let's move on to the third program, HeidiSQL. In this case, the inventory specialist is asked to create commands in a text file. How effective in this case do you think the inventory specialist's work will be as an inventory specialist? However, I'm waiting for your comments. Feel free to send them in. Maybe you think one of these 3 programs is convenient to use. Let me know. We, on the other hand, offer a method where the inventory specialist is encouraged to focus on performing their direct duties, rather than thinking about how to create an SQL command and how not to make a mistake. In LabVIEW, the inventory specialist clicks buttons, not Stack Overflow tabs. So let's return to our DBTool program and try to perform a search operation for a value in a table. I have the inventory table open. It's a small table, but let's assume it has 1 million rows and we want to find how many tables, for example, we have in the warehouse. Instead of composing an SQL command, we simply type the word table into the search window, select the column where we want to find this value, and press the search button. Or, for example, not for an inventory specialist, but for an engineer, we want to find measurement values taken under index 15 and 16. Instead of creating an SQL command, I simply enter 15, 16 into the search field and select the column, in this case index ID. This is what engineers love. Fewer commands to remember, more time to actually engineer things. Let's compare this with what is offered to us in the previous programs. We can assume, and I can state, that this method takes much longer to execute. The probability of error is much higher, and overall it distracts from the actual task at hand. In some comments, there were suggestions to use PostgreSQL. Let's compare how the search mechanism looks in PostgreSQL. As you can see, on the right side, there is a function created that performs a specific task. If we assume that this function is already created and fixed, then we can use the search command as a function. But if we need to change something, for example, the search object or the column, we need to modify the entire function. Not only is this inconvenient and time-consuming, it also carries a risk of errors. In addition, the interface itself is overloaded with information that an inventory specialist simply does not need in their work. Next, for example, I want to sort by the column current. I select the column and press the sort button. Or by another column, for example, index ID. All of this happens in a single click. One click in LabVIEW does what would otherwise require a carefully typed command and a deep breath. Or let's compare the table creation procedure. For example, I want to create a table called film. To do this, in the DB table name to create field, I type the table name, and the window appears with DB table column information. Here I enter the column names, for example, column 1, column 2, column 3, column 4, column 5, column 6, column 7, and I choose the cell data type. In this case, it's a string, but I can also choose any other cell data type such as long, single, double, datetime, or binary. I also need to specify the cell size. I must plan the maximum number of characters in this cell. In general, the maximum is 255, but in order not to unnecessarily increase the database size, I'll use 50 everywhere. I also allow null values everywhere. And that's it. The table is created. All that remains is to press one button, create. Or if I want to cancel, cancel. Here, a table called film is created as well. The column names may be different, but that's not important. The principle is what matters. As an employer, I would definitely choose our database tool for my inventory specialist. I won't be repeating why. I think it's already clear why. When your tools are this intuitive, training becomes onboarding, not a survival course. So let's return to our database tool. I press the Create button and look at where the table appears in the database. The database is MES001, and here is the table. Now I'll just fit I'll just fill it in with random data. It doesn't matter what exactly. The point is to show how quickly and conveniently this is done. I press insert button. Insert record. That's it. The data is written to the table. Now let's look at what insert record looks like in PostgreSQL. As you can see, a standard SQL command is created. To create it, my inventory specialist would have to be distracted from their main responsibilities, for example, working on an invoice, where they must accurately focus on items, prices, and quantities, and instead, they would have to write an SQL command. So we've looked at the undeniable advantages of our program database tool compared to other existing user interfaces. Now let's move on to how our button management is implemented in the program. For example, to select the database we want to work with, we go to the database list and select, for example, MES number 2. Let's see how this is implemented at the program level. We find the terminal and the block diagram opens automatically. Here, it's important to note that our program waits for the next command while being in the wait for event state in the event case timeout. In LabVIEW, waiting for an event actually means the program is calm, efficient, and not burning CPU cycles for no reason, which is something text-based code still dreams about. By default, our commands are executed sequentially in the block diagram from left to right. In the DB in use property, we see a string 2D array that contains all the database names. And value represents the current state of DB in use, roughly speaking, the row we are currently on. If we go to edit items, we'll see that by default, each row has its own number, values. So, knowing this number, we select a row. Next, we see the empty array operator. If no database is selected, this condition is true, and we go into the true case. In this case, a window pops up saying no DB exists. And then we reset the DB tables window to the first row, clear all values that were previously there, clear the main DB table, and switch to the enum case, disable controls for DB in use. If a database is selected, we go into the false case and our DB list sub-VI is executed. Let's see how this subprogram sub-VI works. Here we see our standard path lookup procedure, which we discussed in previous episodes. Using the database connectivity toolkit, we open our database. Using the dbTools list tables function, we retrieve all tables names and send them to the MGI natural sort function. We'll now look at where this function comes from. Then we add an empty row at the top of the collected information and get a fully populated database tables list. At this point, let's briefly step away from our program and I'll show you where we get some of the functions that we need or find convenient for our algorithm. Just like in any other programming environment, we use an include mechanism to add applications, libraries, and files. The same concept exists in LabVIEW. For example, if we open the Arduino IDE, where we program in C++, in Sketch, include library, manage libraries, we can add any library. A similar mechanism exists in LabVIEW. For this, we use the VI package manager. Here, I searched for MGI, and in this case, MGI is already installed on my computer. To install all functions at once, I select MGI tools instead of installing each function separately. This installs all related functions, and they become available in the environment. We'll talk more about this tool and how to add functions in future episodes. The function we use here, MGI natural sort, is located in the programming menu, MGI, 1D array, natural sort. To use it, We simply drag it onto the block diagram and connect it to the terminal. That's how a sub-VI works. After it completes, we populate the database tables window, clear the DB table, and move on to the next enum case, enable controls for DB in use. This is one of those moments where LabVIEW feels less like programming and more like designing a smart machine that already knows what the user should do next. Here we see the logic we discussed in detail in the previous episode. And in the next episode, we'll start breaking down the SQL commands used in our functions. And that's all for today. Thank you for joining LaPlante Tech. If you have any questions, please leave them in the comments. If you learned something new today, give this video a like and subscribe to learn more from upcoming episodes.